Welcome to Moving Up the Monitoring Stack. I'm Steve Murawski. I'm an advocate over at Microsoft Azure. Focus on topics in the modern operational concepts, DevOps, site reliability engineering, cloud native stuff. And today we're going to be talking a little bit about monitoring here. And we're going to draw primarily from two sets of practices, DevOps and site reliability engineering, or SRE. And I want to be clear about what practice we're talking about when we're talking about it. So there'll be like a little banner up in the corner if we're drawing from something specifically. And DevOps and site reliability engineering. DevOps is a little more fuzzy. Site reliability engineering tends to be a little bit more prescriptive. But there's a lot of shared practice between them. So I like drawing a little bit from both of those. We're going to draw a good bit of inspiration today on monitoring from the site reliability engineering space specifically. What do I mean by site reliability engineering? I'm not going to read the whole definition to you here, but there are three crucial words in this definition: reliability, appropriate, and sustainably. And we're really going to focus on the first two, reliability and appropriate, in this talk, because they tie really closely to why and what we want to monitor. The sustainably comes in when we start talking about what do we actually alert on. Because we want to make sure that when we alert, we're alerting in a sustainable fashion, such that we're not going to burn out our people with alerts that they can't do anything with, waking them up in the middle of the night for things that they can't respond to. Right, and actually, email is not a wonderful place for alerts, right? Emails tend not to wake you up at night, and if you get woken up by email, I feel sorry for you because you probably have not had an unbroken night of sleep in a long, long time. Email just tends to keep coming on in. But one of the things when we talk about appropriate levels of reliability, right? 100% is not always the right answer. It's the right answer when we're talking about the plane carrying me here, or it's the right amount if we're talking about like a pacemaker or something else, but something that's responsible for people's lives. But if we're talking about like network connected services, 100% reliability may not be what you need, because the network connection between your customer and that service is probably not going to be 100%, right? And you lose some of the ability to experiment and to make changes when you tie yourselves too tightly to a particular reliability metric. So one of the things we're going to talk about here is how do we have the conversation around what is that appropriate level of reliability. All right. So why do we want to monitor? Primarily, right, we want to monitor to make sure that the systems that we're responsible for, the applications and the infrastructure, because the infrastructure in and of itself doesn't actually accomplish any goals for my organization, unless you're an infrastructure provider. If you're Rackspace or Azure or AWS, equation changes a little bit, right? But in most cases, who here runs infrastructure? Who here runs applications? All right, we got a good bit of overlap there, right? It's the applications on top of the infrastructure that bring value to our organizations, whether they're internal facing or whether they're customer facing. So we need to make sure that those things are behaving as we expect. It makes no difference to my organization if my IaaS server is running and is up and available 100% of the time if the application is crashing every 5 minutes. Right? That doesn't help my organization anyway. It narrows down what we need to troubleshoot, but from the organizational perspective, it doesn't actually accomplish our goal. So we want to make sure both the applications and the infrastructure are doing the things that we expect them to do. Same thing. If the application never throws an error, but the infrastructure doesn't stay up, again, we have to have a combined view of what we're looking at. And not only is it doing what I expect, is it doing what our users expect. Our users aren't going to use the thing if it doesn't do what they expect it to do or what they need it to do. Are they using the features that we've enabled and that we've paid for and we've spent dev time on, right? If we've spent 6 months building a particular capability set, but no one ever goes to use it, right? Do we know that? Do we know not to keep investing down that path and move to something that matters more and is going to deliver value to our organization? And we want to make sure we're accomplishing our organizational goals. This could be meeting service level agreements with customers. This could be, just being able to be in contact with our customers. This could be supporting internal business operations. Is the application actually meeting the goals? Are we having successful transactions? Are we, or are they dying out in the middle somewhere? And we need to measure so that when we change something, we know if it's working, not only still working, but did the change that we made improve or damage the environment in some way? So, Mikey Dickerson has been, I think he was at Google a while back, spent some time in the site reliability engineering space. And so he's got a little hierarchy of reliability, right? And all of this other stuff, our user experience, our development experience, our incident response, all of those things hinge on a good platform of monitoring. We need to know and have visibility into what is happening in our environments in order to effectively do all of these other things. Now, I am horrible at making slides, so I stole some of these from a colleague, and he's the one that does the fun stuff and makes it change colors, and I'm not very PowerPoint skilled. So, how do we start framing our monitoring in a way that we can meet some of those goals and some of those purposes that we just talked about, right? If I start sharing, disk queue length and percent CPU out to the rest of the organization, what does that actually mean to them, right? It means nothing, right? It only means something to us if we were born or if we were doing IT back in the 1990s and disk queue length meant something, right? That's not as big of a deal anymore. But really, what it means is we've gotten applications, we've put them in our environments, and we instrument the environment because that's what we have control over in order to assume things about how the applications are performing. Maybe you have some instrumentation in your application. Maybe not. But we start to build a monitoring structure around observing the environment around it so that we have an idea of what's behaving there. Back when I was at Stack Overflow, we had a dashboard that showed like the CPU and memory utilization of servers across like the web tier and our database servers. And at the time, now it's been a few years since I've been there, so tooling's changed some. But at the time, not really, but somewhat, right? But the people who had been there for a while and had built up a ton of intuition about the environment. And so you could look at, and if you saw the web tier using more than 10 or 14% CPU, something might not be right. Did an application just get pushed out and now there's some jitting happening? Or is there something actually wrong in the code base? Or is there some sort of oddity going on with WebSockets or something? You could tell because you knew how these things ran over time, that something was off. That's not always the case, right? Especially you bring in new people, they need to learn all these things. They're very often not codified or written down anywhere. And so when we get an alert that CPU utilization's high or memory utilization's high, what does it actually mean? What am I supposed to go troubleshoot? When I get a phone call saying, hey, the SQL server's at 70% CPU utilization and it's Sunday, we're not going to survive Monday. What's going on? What are my indicators? What what am I actually going to go troubleshoot and try to figure out what's wrong? So we're going to introduce the idea of service level indicators and how we can use those to help take the measures that we're familiar with and maybe some new ones and use those to define a language that we can talk about effectively in determining, are we running well? And when we go to change things or when something is wrong, that we have a direction to go troubleshoot and try to figure out or even gauge whether troubleshooting matters. So we have kind of this nice little funky diagram here, and I'm just going to populate it for interests of time. We have a number of components that all come into how we measure reliability. There are some that you may have thought of already, like throughput and latency, right? You want to know how quickly requests are being resolved. You want to know if the fidelity, are these transactions coming through properly? Are they getting stored properly in the database, durability? Right? Am I getting current information or is it cached? But together, all these different types of evaluations play into the reliability of our systems. Now, it's not just about my perception of reliability. What we really have to focus on is the reliability in the terms of the customer, the consumer, or the user of this service, right? That could be another business component. If we run APIs, it could be end user stuff. It could be client devices, right? So all of this stuff, we need to frame it back through to what does this matter for our customer? So, service level indicators. These are a ratio or proportion. For example, it could be number of successful HTTP calls over the total number, right? Because it's a ratio. Number of operations, qualified responses, records processed. Some of these things are things that we can watch at our load balancer. Some of these things are things we're going to need some application information to know about, right? So we can't just rely on things like CPU utilization, right, in and of itself. It's too generic of a measure, and it doesn't correlate tightly to a particular problem. Now, there's one other component of our service level indicator, and that's the how. Remember when I said that this has to be we have to think about this in relation to the client? Well, these numbers matter based on where you collect them. For example, if we were talking about the successful HTTP calls, as measured at the load balancer is going to be different than if we measure successful HTTP calls from the mobile application or the web browser, or what the web server sees. Some failed calls may never make it past the load balancer, right? So where we measure matters because it's going to assume, we're going to have to then assume that a class of problems that we're not even going to, that's not even going to respect. User says, hey, I can't connect from my application into our service, and you look at your service level indicator and, oh, all the requests are being answered successfully. We're doing just fine there. But if the request is never making it from the application because DNS is wrong, that's not going to surface your problem. So by stating where we're going to measure these particular values from, we can identify gaps in where we're going to need to troubleshoot when things go wrong. Now, we've all had lunch, so we're probably on the downswing a little bit. So let's do some math. Now, I promise the math will be simple. Well, at least it will be. At least it won't be too hard for me. I'll use nice round numbers. So if I have 50% or 50 successful HTTP calls out of 100, that gives me a ratio of 0.5, right? All look good? Nice, easy numbers? And to get a proportion, that gives me 50% availability. That's really all, that's what we're looking at, right? Now, as I was just saying, we have to look at where these numbers come from. They could be reported directly, reported by the clients, reported by the applications that we're hosting, right? There are a number of places in which we can get these details. But we do have to make sure we recognize those trade-offs. It may be easier to get those HTTP stats from our load balancer than trying to collect and upload them from all the client devices, or instrumenting the application with the JavaScript to report that back. And guess what? If our load balancer's got problems, our data reporting on our metrics is probably going to have problems too, right? So there are trade-offs from where we're going to capture these bits of information. This does then bring us to a little bit that is hidden partially by me standing in front of it, but we're going to need to trust our monitoring and telemetry. If we're going to use that to drive our alerting, we're going to use that to drive our availability metrics that we publish and share, we need to trust the data that it's capturing. So that means we need to have tested and validated that collection infrastructure. Are we dropping events, right? John and I were having a conversation the other morning. Like, how do we validate that the log aggregation is going to keep up with the environments, with the needs of the environment, right? And what other stressors do we have to take into account for that for that type of thing? Those are some of the trade-offs that we have to know, and we have to build that level of trust that we're getting enough good information. Now, service level indicators in and of themselves just give us a metric. They don't actually give us a target. And so that's where we come up with service level objectives. Now, service level indicators and service level objectives, they sound very similar to service level agreements. Anybody responsible for service level agreements? Handful of folks. If you're not, you probably are somewhere, but no one's actually said something about it until there's a problem. That's when you find out. That's when you tend to find out a lot more about those service level agreements. One of the challenges with service level agreements is they're a little fuzzy on technical detail. Service level indicators and service level objectives allow us to put hard numbers and behaviors, as well as the qualification of where we're collecting those things from, to those service level agreements that we have, or to those internal agreements that we have about service performance. So service level objectives are the next thing we're going to look at. Oh, and I don't know if you've noticed that nice little raccoon guy there. I think he's on my sleeve too. If you're wondering who that is, that's Bit. He is our team mascot. There's a bunch of Bit images out in a GitHub repo somewhere, doing all sorts of fun stuff. But that's neither here nor there. Let's talk about service level objectives. All right, the recipe for a service level objective, an SLO. First, we have the thing that we're measuring. And continuing with our successful HTTP request, we have our SLI proportions. Right? We want to make sure that 90% of them succeed. And then the last bit we need to add is a time bounding. Right? Because I can make my service level, I can meet my service level objective if I can control the time bounding. And it's not specified, right? I can manipulate that report to look like, hey, everything is perfect, and I just gave you a 3-second window, right? For these 3 seconds, it was perfect. So we want to make sure that we have some sort of time bounding expectation in our service level objective. And the time bounding may be in the last 30 days. It may be and which could roll forward. So, it's going to be today's 30-day window is going to advance one day, or it may be the last calendar month, or maybe the last couple week period, or it might be the last 5 minutes. Whatever is going to be effective for your reporting requirements or for your availability requirements, that's what you're going to take advantage of for a service level objective. All right, so here's how the stuff plays out. We have a service level objective that kind of gives us our measurement, right? We're going to monitor it and figure out if things are good or not so good. And when they're not so good, that's when things fall into that incident response stuff that we talk about a little bit, and people start getting on conference calls, and VPs start stalking the halls looking for people to fire. Key thing to remember, key takeaway here: you cannot fire your way to reliable systems. It amazes me. Organizations try. I've worked in organizations that have tried this. It does not work that way, right? Because when we try to fire our way to reliable systems, what we tend to do is make it much more difficult to discover what actually went wrong, because you're actively incentivized to minimize your role in things and maximize others' roles in things. And so you're not getting an accurate reporting of how did we come to this bad situation. Now, the service level objective can be more complex than just that one measure. They can be compound metrics. They can be segmented, right? We can apply all sorts of statistical and mathematical equations and all sorts of logic to these things to make them more complex to meet the needs of our organization. So while CPU utilization alone might not be a great service level indicator, CPU plus memory pressure plus completed calls or something to that effect, or number of exceptions or something like that, can be a very effective measure. If I have high CPU and high memory pressure and a ton of exceptions, that could lead to me to think that, hey, there's some code path that's blowing up in my application that's chewing up a bunch of processor, and maybe we should look at when our last code push was, or take a look at our application instrumentation for a little more detail. But it leads me to believe that, hey, there's something there. Or it's going to eliminate that as a potential possibility if we don't actually cross that threshold on exceptions. So the compound service level indicators and objectives give us the ability to take some bits of disparate information that by themselves don't lend themselves to figuring out exactly what's going on without a lot of intuition about the environment. Because we cannot rely on that environmental intuition. A lot of times I'll hear people say, oh, job security. Yeah, if you never want to improve your career or you want to, screw over the guy that comes next, that's usually not a great way to live and work. So, where do these numbers come from? How do we figure out that 90%, I want 90% of these things to succeed? Well, it may be customer expectation, right? When I connect to Amazon to buy stuff, which I do way too often, I expect that when I click, the one-click buy, it should buy it and send it to my Kindle and give me more reading material for my flight home. When that doesn't happen, I'm sad, and then I hit the button again. But we have customer expectations, and they could be internal customers, external customers, on how these services are consumed. For example, Stack Overflow. I expect Stack Overflow to always be up so that when I have a question, I can either go ask it or I can find the answer because somebody's probably already asked that question. However, I'm not giving Stack Overflow any money for that privilege. So my expectation may differ from the business drivers that they have for making that server available. So my expectation is going to be weighted appropriately based on my use and value to that platform. Some other data, right? That could be my particular value to Stack Overflow as eyeballs that come to look at the advertising. Or while I'm there, maybe they can get me to go answer a question, right? That's other data outside of the customer expectation for what that service availability should be. So if that service is down, if Stack Overflow is in read-only mode, I can't go answer questions. So my value to their ecosystem drops. Not very much because I'm not very good at answering questions. All the questions I could answer have been answered by somebody else. But it reduces it in some way, shape, or form. We may look at how does the service run today? What are our stats for availability? And we're just going to build around that. We're going to say today is good enough, and that may be all right. Now, what we want to watch out for in that case is if we're saying things are okay today, are we actually meeting our current agreements? Or is it just slightly to the point where, like, if I start publishing my information about these service level indicators and objectives, am I going to get us out of compliance? Because today's not really in compliance. It's just slightly down enough that people don't know. So, how do we get from here to there? Well, we'll come back to this. I'm going to show an example of how we create a service level indicator, a service level objective. I'm going to use Azure and App Insights. Oh. So we are in Azure, and I've got an application running. Oh, you bet. More better? Okay, so we've got an application, and there we go. So it's an internal application to a company, Tailwind Traders. Anyone remember Northwind? Northwind database, right? So Tailwind Traders is a born-in-the-cloud company, and they've acquired Northwind. And so we have a application here that is it's several components, for the most part that don't matter to this talk. But there's one component in particular, and that's the legacy inventory system that we have running. And it's a .NET application connecting to SQL Server. And I've sent some API traffic to it, and that service provides the inventory counts for our lovely products like this small soft shoes. And these look actually like a lot like, those are not soft shoes. Those seem like very hard shoes. But the inventory service allows me to increase or decrease the available number on our internal inventory app. So that's the application that we're working with. The inventory app is just an API, so there's not really anything much to look at, which is why I showed you the other one. And it's running in Azure App Service, and I've got it wired up with Application Insights. And what we can do is, again, not friendly to my neck, is we're going to our Application Insights for the inventory service. And we can get some basic information from here. There's nothing lately that's been happening, but we can look over the past day. So it's going to give us some stats and App Insights, but this isn't really what I want. What I really want to go is into this analytics. And what the analytics is going to let me do is use the Cousteau query language, and there's other products and projects that allow you to query over your data sources. We're just using this one as an example because I have all sorts of Azure credit, and that works out well for me. And Azure pays me, and so I like to show Azure, right? But what we want to do is define a query that's going to pull back data to define our service level indicator and service level agreement. And I'm going to bring my mouse back here. I've got, so you don't have to see me try to type this out. I've got it handy, because I would not remember this. But we can look at the requests table, look back over our 30-day window, and we're going to look for successful requests over total requests. And we're going to define a metric, our service level indicator and percentage, and we're going to project that out onto a table. Or, I'm sorry, onto a graph. And let's... No scroll bar on the side?
Scroll the lower one a bit to the right.
This one?
No, all the way down. Okay?
Ah. The other scroll bar. Got it. Not that scroll bar, the other scroll bar. Oh, here we got a little claps. There we go. So we can look and we see, we see a nice little metric there. But I'm going to, let's see. Come on, there. I'm going to change the time bounding, because right now it's by every hour. And let's drop that to 30 seconds. Because when you send a bunch of scripted traffic, it all happens rather quickly. All right, let's take a look now. We'll close this up. So we get we get a little graph here that shows, hey, we've got mostly good, but we've had a couple instances where we drop some traffic. My totally arbitrary bad traffic that I threw at this thing. But we see our service level indicator value, and gives us a way to capture that metric over the period of time. But we also need to know the objective. Am I meeting my service level objective, or where did it drop below my service level objective? So to do that, we can add a few more little bits. To our query. And get rid of this. And that. So now we're going to define another variable for this query. We're going to say our service level objective is 90%, and then we can put all of those things onto the chart. Now, if you are doing stuff in Azure, you have log analytics and query. All available to you, which is nice and handy. And you can take these queries and embed them into custom reports, into your dashboard, and you can use them to trigger alerts, which is a fun demo session. Here we go. You can also use them to trigger scaling rules. So you can use some of these compound criteria to evaluate whether or not it's time to scale your service, as opposed to, hey, just watch the CPU utilization. So now we have our green service level objective, and for the most part, we're meeting it, but we had some trouble here. Probably a bad deploy, or an application that was requesting something that didn't exist. But now we have a nice little graph backing up the service level indicator, service level objective, and when this alerts, I have context now for where I might be potentially troubleshooting. I know somewhere between my load balancer and my application, things are not going well. And I can look into my other logs, and I can at least take advantage of that to know where to start troubleshooting versus, hey, there's just some problem, or maybe I got an email, hey, I can't use your service. Or in the case of when I was at Stack Overflow, very often Twitter was the first one to notify us that something wasn't going so right. Is that still a handy alerting tool, or? Right. Yeah. When you've got a high demand service, while having your users tell you that there's a problem isn't always the greatest thing, sometimes that's just how it behaves. All right. We've got a few more slides to get through here. We'll go back. All right, we transition. So it likes extend. It does not like duplicate from my laptop. That's okay. I can live with that. I will remember that for tomorrow. So, how do we get from where we are today to implementing some of those, to implementing some of these concepts? A lot of our traditional monitoring tends to be, here's a bunch of perf mon counters, here's a bunch of application metrics, monitor these things, and then do some guessing, right? Doesn't always work so great. Especially when we start transitioning into cloud environments. Because now I don't know the hardware exactly underneath. I don't know if I've got a noisy neighbor or not, or what happens when I start to move my app from a VM into app service or into a container. How do I watch percent CPU utilization in that case, right? The metrics start to, and how do I actually evaluate that contextually if I can get that metric? We can't count on those metrics to be there, but you all have something that's extremely important. And that's the context that you've built up about how these applications run. And so working with your customers, working with the developers responsible for, or the third-party software that you're running, or whatever, you can help build out what the real metrics are that are going to matter, regardless of the environment that you're running in, that are around the behavior of the applications on the infrastructure that we have. And it may be utilizing some of the older metrics in conjunction with some of the application metrics in order to come up with the right service level indicators and objectives for our environment. But if we want to be in the right place to protect our investment in experience as we move to more cloud-style environments, whether that's a public cloud, or whether that's something you're building internally, or whether that's something that's being completely hosted in a managed service somewhere, right? We want to make sure that we have a role in defining what good looks like for our applications, what effective looks like, what reliable looks like. So we bring that context that we have for running these services, maybe I captured a bunch of logs, a bunch of performance counters, and I shoved them into the performance analysis and logs tool. Anybody use that one? PAL, it's open source project. Great tool for monitoring around a system that all sorts of inferences have been made already because somebody knew the product and they took their context and they put it in a tool, right? But it all relies on understanding the machine level performance. We lose some of that when we move to the cloud, and that can be scary because now you're responsible for the performance of your infrastructure, but you don't have the same level of visibility into it. So we have to know how we can say, no, guess what? Our application's performing as expected or as it did before, even though we're running in this different environment. Or, hey, it's not performing as before. We need to increase the resources that we're assigning to it. Or maybe we need to scale it out, scale it up, whatever the appropriate thing is for that particular application or resource. right? This helps us build that comfort level as we start to transition. Right? Now, I've kind of talked through like, hey, what goes on? Hey, CPU utilization's high, page file, all that kind of stuff, right? But we're not getting any other context. How do we deal with that? What do we actually transition our monitor and metrics to? And that's where, right? That's where we start to ask questions like, what is it actually telling us about the application behavior? What mitigation strategies can we look at? How would we run this if it was running an app service or some other PaaS environment or on Heroku or whatever, right? What other measures might we use to troubleshoot this? Now, as we go on from here today, if you want to dive more into the concept of service level indicators and service level objectives, there's some great reading in the site reliability space. Kind of the definitive work from a number of folks over at Google at the time. Then we've got the site reliability workbook. Seeking SRE is a bunch of gathered stories around site reliability engineering topics. We've got some content from last year's Ignite around site reliability engineering concepts. There's some really good stuff from a number of different places inside of Microsoft who are transitioning to site reliability engineering. And we've got Learn module, and we've got there's a Learn module under development on service level indicators and objectives in Azure coming very soon to a Microsoft Learn near you. Anybody use Microsoft Learn before? So it's an online learning platform, newly or relatively new in our ecosystem, but it's nice. You got some gamification, badges, all that kind of fun stuff. Anyway, I'm here all week. If you have questions or want to dive deeper into any of these topics, otherwise you can find me out on Twitter. That's probably the most efficient way to get hold of me. Email tends to be a little slow, but otherwise, email is firstname.lastname@microsoft.com. So, thank you all very much, and enjoy the rest of PowerShell Summit.